Hi, I'm Kerry Morwidge. As the chair of the marketing department, I'm delighted to welcome you all to Questrom today for today's exciting exchange of ideas about the shifting landscape of digital marketing. As Raj has outlined in his provocative talk, in the last decade, particularly in the last year, we've seen breathtaking technological innovations in this space, such as large language models. The next challenge is really working out how marketers can use these technologies to create values for firms, their employees, and consumers. And our panel of scientific experts each approach this issue through a different lens. Ayelet Israeli is a Marvin Bauer Associate Professor at Harvard Business School and co-founder of the D3 Digital Design Institute. Ayelet will be sharing with us how to augment market research with generative AI. Sad that you can't just have ChatGPT generate all of these insights. Okay. DK Lee is a Kelly Questrom Associate Professor of Management, Information Systems, and founder of the Business Insights through Text Lab at Questrom. He'll be speaking to us about the use cases of generative AI for harnessing human creativity in art. And last, Garrett Johnson is Assistant Professor of Marketing. Garrett is an expert in digital advertising who's changed how firms like Google measure which ads work. Garrett will share his vision about the future of conversational search, what it means for advertisers and search engines. So please join me in expressing our gratitude to these speakers for sharing their ideas today. Thank you.
Thank you, Carrie. Can you hear me? Yeah. Do we need to adjust anything? No? No, I have a lapel. Cool. Hi, everyone. My name is Ayelet Israeli. I'm a marketing professor at Harvard Business School. This is actually joint work with Jimbo Brand and Donald Way, who are at the office of the chief economist at Microsoft. So it's an interesting collaboration. So just to set ideas, I'm going to be talking about large language models, or in particular an application of large language models. When I first created these slides, not a lot of people knew about these, but now I think most people have experienced GPT in some way. But just to remind us all what is going on, these large language models are essentially designed to understand and generate things like human-like language. They're trained on huge amount of text data. Essentially, we can think about them being trained on the entire internet. And they kind of generate text based on the most likely next word is a way to intuit it. Really, there's a whole distribution underlying, and based on context, based on kind of choice probabilities, it generates next words and text. And we've seen this for years. So if you are a Gmail user, you are always recommended how to continue the text, but now it just became more common knowledge with OpenAI's GPT. And we think about wide range of applications, and we'll hear about some of these later as well when some of my colleagues present. But really what I'm going to focus on specifically is OpenAI's GPT. And I'm going to focus, so a lot of you have probably played with ChatGPT. I'm going to actually use a different way to get into GPT through an API. So I talk to it directly and not through chat. And I'll explain later why it's important in my context. So, we've all seen examples like this. GPT can really improve productivity. For example, when I created these slides, I went to GPT and wrote, please write the first slide of a presentation about using GPT for market research. I didn't give any other context except just the title of my presentation. And there's a whole slide. First of all, there's some judgment. The title that they suggest is leveraging GPT for market research, not using, so I kept mine. But introduction says market research is crucial for businesses to understand. We can argue with Raja if it's crucial or not. I think it's still crucial. He was more thinking about how do you actually do it in this day and age. And then traditional market research methods can be time-consuming and labor-intensive. They have limitations. It's hard to scale, et cetera. But GPT, so GPT is now talking about itself, has revolutionized, right, the field of natural language processing, offering new opportunities for analyzing vast amounts of data. In this presentation, we'll explore the potential of GPT models for market research, including now is the part when GPT starts making stuff up or hallucinating. I'm not going to talk about any of these things. Instead, I'm going to talk about how to use these type of models to uncover customer preferences and conjoint analysis. But all in all, pretty good job. Now, this is what the feature we typically think about ChatGPT. How can it help us by giving us an answer and using that to reduce the time it takes us to do a task. But another thing that GPT can do is actually kind of simulate humans. So we've all seen examples of kind of, please respond as Steve Jobs, Albert Einstein, whoever your favorite persona is. But we've also seen in academic research that you can tell GPT things like, what is your political ideology, and replicate things like voting behavior. You can replicate results of classic experiments, both in psychology and in economics. So to us as social scientists, this was really interesting, and it tells us, maybe we can use GPT in some way for social science research. Because I'm in marketing, I was interested to know if I can use GPT for market research. And so the research question that we really had in mind first is, are the responses that GPT generates, are they aligned with fundamental properties that we think about in customer demand? For example, demand curve is downward sloping. Is this really exhibit responses? Does it understand if I offer it something for $1, it should say yes, but if I offer a cookie for $100, it should say no? Does it understand that? And B, the second part is, are these responses actually realistic and meaningful? Are they grounded in reality? And this is exactly what I'm going to look at. So just a preview of the result. The first question, does it exhibit kind of fundamental properties of consumer demand? The answer is yes. Otherwise, I probably wouldn't be standing here, or would be standing here telling you how to not use GPT for market research. But essentially, we document things like downward sloping demand. We show that income actually affects how you perceive demand, and something like brand preferences that I'll show you in a little bit. And then, are the responses realistic and meaningful? I'm going to show you that GPT actually generates pretty realistic willingness to pay numbers, and these are very consistent with human studies. So there is something here where it provides me that information. So let me talk a little bit about how we actually approach this. How do we typically learn about customer preferences? Raja was just telling us how awful focus groups are, but this is kind of the way we do things, right? We need to look at a lot of consumers. We want to talk to as many as possible in our target market. We do surveys. We sometimes use observational studies to see what they chose, what they had in front of them, and what they chose. But all of these are costly, time-consuming, labor-intensive, and sometimes we kind of don't really have the data or have to wait too long and don't really look at it. And so our first question was, can we actually use GPT to emulate kind of human data collection? And the answer is yes. And the way that we approached it is we decided that, we can actually query GPT hundreds of times for each option that we provide, for each bundle of goods we consider. And the responses that are generated give us a random sample of consumers. As you know, when you talk to GPT, you'll get a different answer every time. When you use the API, you can ask, how random, how much from the distribution of possible responses, how much can you draw? So that's how we use the API to actually maximize the randomness of responses to query a lot of different types of consumers. And we think that this probably works because the training data has a lot of information from all the internet. It probably has user-generated data like reviews, blogs, maybe even how they interact with ads, things like this. So maybe there's something informative there. But really, the hypothesis is that just as when we query GPT, it produces kind of the next most likely word or some probability like that, maybe if I induce it to make a choice, the choice that it gives me actually reflects some underlying distribution of preferences of consumers. And that's kind of the hypothesis and what we're testing here. So we tried to do exactly that, emulate customer surveys. So we asked GPT to fill in a response to a survey as if it was a customer that was shopping in the category of interest and was randomly selected to participate in a survey. We describe some features of the customer. Here, I'll show you examples with income. We've also done this with other demographic characteristics. And then we describe either 1 or 2 products, as well as the option to not buy anything. And we ask GPT either, make a choice or giving us some willingness to pay or something like this, exactly like we would do with customer surveys. And like I said before, the key is that we repeat each prompt hundreds of times to generate kind of a distribution or to simulate the sample. We have 6 studies. I'll show most of them to you. And I already discussed, what I'm going to show. So let me just move on to that. So the first study we went for was, to understand if GPT generates a downward sloping demand curve. It's a fundamental property that we believe in economics. And we started with a binary choice, and then we moved to also choice among options. So this is the exact prompt that I use. A customer is randomly selected while shopping for laptops. Their annual income is $70,000. That's the median income in the time the GPT was trained. And then I say, while shopping, the customers see a particular laptop. I give it all the different specs. Price is in red because I'm actually going to ask this for different levels of price, because I want to see that for different levels of price, it will give me a different answer. And then I say, the customer is asked after they finish shopping, did you purchase any laptop? If so, which one? And I do this customer : to tell GPT, give me an answer as if you're a customer. And it understands it through this API. So essentially, that's what I do. I vary prices for different levels. And for each price, I ask this 300 times. So for each price, it's like I asked a survey of 300 consumers. Or that's the idea we're trying to do. And I get responses. And responses look kind of like a customer response. It says, yes, I purchased it. I did purchase it. It's perfect for me. No, I actually didn't purchase. It wasn't right for me. It's too expensive for my budget, et cetera, which is pretty amazing. We can study a lot here from how choices are made. But all I cared about at this point is just the no and the yes. And I'm going to calculate for each price level how many said yes and how many said no, and plot these shares. So this is kind of the responses. These are different prices of the surface. And these are the shares where GPT chose that it's going to choose surface. Now, if we squint, it's kind of downward trending. Is it always like a nice slope? No. Do we always get a nice slope when we ask consumers? No. So we see this more as a feature than a bug. But also, this is not ideal, right? What we do in customer surveys is actually, we learned that if we give 2 choices, responses are more realistic, and we wanted to see if it's the same with GPT. So we repeat the exact or almost the same thing as before. The only difference is now I give it another option. I'm going to offer either the Surface or the MacBook. And for the MacBook, I'm going to even keep the price constant. So there's always a constant comparison, and I can learn that relationship. And so when I do that analysis, the curve looks much better, right? It's downward sloping. GPT is price sensitive. I see that reference price matters a lot. When the price of the Surface becomes less than the price of the MacBook, demand drops by a lot. I also see that GPT kind of has brand preferences. What do I mean by this? Even when Surface is very cheap relative to the MacBook, only 50% of consumers pick Surface. So it prefers Apple. When they have the same price, Surface shares are only 40%. So it still has this underlying preferences. And that was really cool to us and interesting to us. And we replicated this with other things. So the first thing we said, okay, maybe computers have a lot of reviews online. If I look at something like a supermarket good, it's not going to have that much information. Maybe I will learn something different. So we used toothpaste. You'll see later why. But I essentially gave Colgate and Crest. Prices are much lower, between $2 and $6. But otherwise, it's a very similar setup to what I just said. And we get, a very nice curve of shares. We see here that toothpaste is not as differentiated as laptops for GPT, meaning when Colgate is cheaper, it's most likely to choose Colgate. When Colgate is more expensive, it just chooses Crest. There is not that much preferences as we do see in computers. So we're really excited by that. And then we wanted to see, well, does income actually impact what GPT is going to choose? So now we just varied the income. We gave it, before it was $70K, but now it was either $50,000 or $120,000 of income. We ran the same queries as before, and we see that when you have a higher income, your demand is more flat, which is exactly what we expect, because the prices are not going to affect your choice that much, because for you, it doesn't matter a lot if it's $1,100 or $900, relative to the red curve with someone with a lower income, where these price differences matter a lot. The next thing we wanted to see is this property of, does your past choice, does your past behavior actually impact your future behavior? And so we went back to the supermarket, we went back to toothpaste, and we told GPT, this customer bought the Colgate last time they shopped for toothpaste. So we gave them this information, and then the results are the blue one. The red is the results I showed before. And we see here that as long as Colgate price was lower, it actually switched the shares to 100%. It understood that it really wants Colgate versus Crest. Once the prices are higher, there is a little bit of variation. But this is something that, the past choice actually is informative to GPT in the way that it makes choices. So that was kind of the next thing we learned. So overall, we saw that GPT responses correspond with what we expect in terms of consumer demand. Number one, there is downward sloping demand curve. Number two, income impacts demand in the way we expect. Number three, state dependence, or this idea where if I bought something before and I know it, it's going to impact my future purchase. We also tried something I'm not showing you today. You can read it in the paper, diminishing marginal utility of consumption, that there's minimal evidence of that, but we have a whole discussion in the paper about this. So armed with this, we said, okay, this is pretty exciting, but can it actually give us something meaningful, realistic? Does it actually transfer to real life, or is this just a simulation model that economics and marketing students can learn? So our approach is twofold. First, we wanted to see if we can get realistic willingness to pay for products, and then whether we can get realistic willingness to pay for product attributes. And I'll explain in a moment why we wanted to do both of these. To recover willingness to pay for products, this time we didn't give GPT any price. We just told GPT about the specs of the particular option that is chosen, and we asked, what is the maximum price you would be willing to pay for this laptop? And so we again get a lot of different responses, and the responses again include explanations which are very similar to what we would get from consumers, right? My annual income is $70K, so this is within or outside of my budget. I understand this is a high-end laptop, so I'm willing to check this, but I'm going to check online and compare all of these things that we expect someone that writes a blog that explains to people how they should buy a computer. That's kind of the information that is given here, and that's based on that GPT generates responses. And then we plot the distribution of responses, and we see here that actually the median price is very close to the actual price. The $999 we used before are the actual price. And the distribution is pretty realistic. So it doesn't go above $1,600. It doesn't go below $600. It's within the prices of laptops. Now we said, again, maybe for laptops it has really good information. For other things, not so much. So we tried a bunch of other products in a bunch of other contexts. Specifically, we went either to the supermarket or to a restaurant, and we used toothpaste, wine, and soda. The toothpaste prices were very similar to median price of toothpaste if you go to Amazon. The glass of wine at the restaurant, the median was $15. So we can imagine which menus it learned this information from. And the range was between 5 and 25. So we know that there are restaurants where you can buy much more expensive wine, right? For a glass of soda, the price was $2.50. Once I use exact soda, but in the supermarket, it realized the price should be lower at $2. So all of this told us, okay, maybe it can say something about prices, but also maybe this information is just in the corpus that GPT is trained on, and it's just giving it back to us. That's not very interesting. And so we were interested to look at willingness to pay for attributes, because attributes is not as likely to be in the corpus of GPT. And we use 3 approaches. Again, the paper describes the other approaches. I'm going to focus on conjoint analysis. But essentially, what the idea was is if I ask it about product attributes rather than product, and I'm going to use the toothpaste example. So if I ask it, how much would you pay for fluoride in toothpaste? Does anyone here have a hunch of how much do they want to pay for fluoride in toothpaste? No, right? Does anyone imagine blogs written about, oh, if you see a toothpaste with or without fluoride, you should pay at least $1 for that? No. So our hunch was this is probably not going to appear online. It's not that kind of information. But maybe if we can still infer it, that would be very exciting. And so what we also did, so we're now running also our own human study. But at this time, what we wanted to do is to compare it to a very new paper. So the idea was this paper is not likely to appear in GPT's corpus. It's a new paper. It's very different context, but they study willingness to pay for fluoride in toothpaste and aluminum in deodorant. And so these are the 2 things we focused on because we wanted to compare our results to their results. And the nice thing, the really good things about their paper is that they conduct a lot of conjoint studies with humans and thoroughly validate that the outcomes actually make sense in real-world data. So we kind of said, okay, if we can come close to them, then we're kind of close to humans, and that's really nice. Our reviewers want us to run our own human studies, and that's what we're doing right now. But that's the way you do academic research. So the idea is, how many of you are familiar with conjoint analysis? Quite a few, right? So the idea is, generally, I can offer people 2 identical toothpastes. One is Colgate and one is Crest, and ask which one do you choose. They're the same price, everything is identical. And by your choice, I can infer, okay, if they pick more likely to pick Colgate, they prefer Colgate. Then I can take these 2 identical toothpaste and start changing more things. Maybe if I reduce the price of Crest by 50 cents, they will move to Crest. No, by $1, by $2. Okay, so their preference for Colgate is $2 more than their preference for Crest. And that's kind of the intuition of how the conjoint work. And it allows me to actually quantify these different things, like how much are they willing to pay for the brand, Colgate versus Crest? How much are they willing to pay for fluoride? How much are they willing to pay for mint flavor? Whatever I want to vary. Apparently, there is cheese flavored toothpaste. So how much would you be willing to pay for that? And some of these can also be negative, right? If you would have to pay me to try the cheese toothpaste. Yeah, it's apparently mostly for pets, which makes, I guess, more sense. But anyway, so our idea was, let's try to see if we can ask GPT in the same way using conjoint studies and whether we are able to reflect these attributes. By the way, when we ask it directly, it does a very poor job. Just like if I would ask you directly how much you would pay for fluoride, you have no idea, right? This allows us also to understand other effects like quantifying or these substitution patterns that I talked about between the 2 different brands and trying to quantify them. It allows us to actually quantify the willingness to pay. And the nice thing about GPT is that it's not bound by humans. in the sense that when you actually run has anyone run conjoint studies in the field? So there are millions of options you can try, but actually humans can only process, I don't know, 10 of these, 15 of these if you pay them nicely. They don't want to run, they don't want to compare these things ad nauseum, but when I do it with GPT, I can actually run and as many times as I want, and it takes minutes. Right? So that's exactly what we do. We use the full set of options. Unlike when you do it with humans, you actually need to identify which configurations are best to present to them. This is the prompt we use. It's very similar to what we used before with the toothpaste. The only difference is, so we vary two things, very much inspired by the paper I mentioned earlier that did this. We use exactly the 3 price levels that they used in the paper. And we vary with or without fluoride, and we vary this for both brands. So when I say here Colgate with, so some people, some GPT queries will see this with, some will see it without. But essentially, I'm going to run all of the different combinations. So 3 price levels times 2 with or without, that's 6. But there are 2 brands, so 6 times 6 is 36 combination, which I run 300 times per combination. So I run this over 10,000 times and essentially collect the results to compute the different attributes. When I do that, the first thing we learned is that the results are pretty consistent with human studies. First, we see kind of substitution effects that we expect to see in humans. Meaning, when the Colgate price is lower than the Crest price, I always confuse GPT with people, huh? GPT is more likely to choose the lower priced item. And the same with the fluoride. The fluoride is a positive thing here. So when one thing includes fluoride and one thing doesn't, it's more likely to choose the thing that includes fluoride. By the way, when we run this with aluminum, it's the same, but the other way around. People apparently don't like aluminum in their deodorant. And therefore, it's a negative effect. And then the second thing we see is we actually calculate the willingness to pay and compare it with the paper. In the paper, the willingness to pay for fluoride is $3.27. We get $3.4, which is much more in the ballpark that we imagined we can get from GPT. So we were pretty astonished by this, especially when we asked GPT in other ways, like, how much would you pay for fluoride? The median and average was $1. So it's actually somehow through this comparison was able to get the similar willingness to pay, similar price elasticity as did the paper that relies on humans. And like I said, we're now running this with more products, with more humans to compare to GPT, because this is one example, and we want to understand how well this can work in other contexts. And we also confirmed this for aluminum and deodorant. In the paper, I think it's minus 1.3, and we have about minus $1 for aluminum. So we want to understand where the differences are coming from. So that was nice. And then, when we think about how do we compare our approach to real-world conjoint studies, well, like I said before, we run all possible configurations. When you run real-world conjoint, you actually have to limit yourself. You have to use hundreds of humans. You have to pay them. It takes time. It's about 15 minutes per participant usually, and took us $3.35. If you use the newer models, it's a little bit more expensive, but still within $30, $100, and not much more than that. With human studies, you actually get the data directly from humans. With GPT, you don't. With human studies, you get the data immediately from each participant. With GPT, we have a script that parses the answers, but we already had that script. So this is kind of how to think about this. Of course, our conjoint is just based on a simulation and not real humans. But we did get very similar results. So what should we make of all of what I showed you so far? So essentially, what we did here is we tried to use GPT as a random customer sampling mechanism and examined the distribution of its response. That's all we did. In the first part of the talk, I showed you that when I prompt GPT as a random customer, it exhibits behaviors that are consistent with economic theory. It's things that we expect, and it consistently does this for by now, quite a few researchers and a few companies that are interested in these kind of things have replicated this and saw that in their own context as well. In the second part, we demonstrated that GPT-based estimates are realistic and consistent with value obtained from existing research, which is also exciting. And both of these tell us that GPT may be able to serve as a powerful tool for understanding customer preferences, because it actually reflects something that is similar to customers. What does it mean? At minimum, this is a simulator. You should use it in your class. You should use it for, when you think of an idea to see what the results say based on GPT. We also know that we can give GPT a lot more information than I have. I can study this for different segments. I can change demographics. I can give it personas. I can use proprietary data of the company. For example, historical surveys that may have some information. And then when I use the historical surveys, when I collect data about new products, maybe that's more informative than just using the entire internet to learn. And we expect that as LLMs evolve, all of this will just become way more useful because of this ability to reflect kind of the underlying information in the text. Of course, I'm not saying so. If you're understood from this is that tomorrow you should replace all human surveys with GPT, that's not what I'm saying. So do not do that. There's still a lot more to learn. This is just one signal, but it's a signal that is based on a lot of information. And we should think about it as that. So we're still working on understanding how useful and generalizable this actually is. We're trying it in different contexts. We're very excited about trying it, especially in B2B context, because so far we focused on consumer products, but doing B2B research is just way more difficult and way more expensive. You need to find, if you're selling computers or software, you need to find the CTOs of companies to interview. Their time is not $3 for 15 minutes. There's a lot of fraud in that as well, so this can be really helpful there. And we want to understand, which products is it useful for, which products is not. Does it do well on future products that don't exist yet? We don't know. We're testing this now. By the way, humans are not very good at that either. So I'm never going to say that GPT we're not saying it's better than humans, but we want to see if it's as good as human. So we think about this as kind of a proof of concept. Can I use it? Maybe if I augment it with some historical information, it's more useful, etc. GPT responses needs to be examined critically in different contexts, like I said. We also already know that GPT has issues of bias. There's also bias that the data is trained on. Not every customer write reviews. There is a lot of people that don't. We're getting to people that have internet connection, that are willing to write, etc. The data is also pre-trained. Right now, it's up to 2021. If I'm asking it about things that are completely new in 2022, 2023, if there are different macro trends, it's not going to capture that in the pricing, and that could be really important if I'm going to price based on this. And of course, you should always disclose the use of GPT, both for ethical and external validity reasons, because at the end of the day, it's a machine, it's a simulator, it's not real humans, right? With that, I'm going to open it up for questions. Thank you. Oh. Yeah.
Fascinating. Okay, first question, Fred Geyer.
I have a really practical question and then a more fundamental question. So the practical one is, if we were going to use it with our students as a simulator, is there anybody who's put it all together as an app that we can just go to and kind of use?
I understand there are companies that do that.
Yeah.
We posted our codes. It's very simple to use.
For you, using code is simple, but not for me.
Yeah. We can think about this. Why don't you email me? We can think if there's an RA that can do that.
And then the more fundamental question is, and I don't know if there's even an answer, but I can think about the training set or its inferences as being made mostly by supply information, not demand information. And I'm sure you've thought about this. Can you talk about that a little bit?
Yeah. So one question is, what preferences are we capturing? Is it revealed preferences or stated preferences? Is it what people say they will do? Use green products or reveal preference, they don't use green products. And we think it's more similar to stated because it's what people report online.
I was getting at something different.
Okay.
Which is if most of the information about products and prices
Yeah.
and features is from the supplier,
Oh.
and that is ample.
My understanding is
Yep.
that a lot of it is not. So there's a lot of user-generated content. A lot of what GPT trained does is things like
Great.
Reddit, reviews, blogs, and that's where you get that type of information. Of course, it's a combination and it's an empirical question, but it seems to us that it's more similar to that. Yeah, yeah.
So I have two questions, both sort of coming back to things that Raja had said. One, that humans are not rational. We don't make decisions for rational reasons. So
Right.
how, using GPT, can you account for people that bought a laptop because it was pink or bought a given toothpaste because that's what they grew up with, or things that waste of time for many years because you're just getting answers to the questions you ask, not necessarily what people really feel. And if this is emulating flawed methods that are flawed with real humans and just replacing real humans with GPT for a method that is fundamentally flawed,
Yeah.
which will give you results that are precise but not necessarily accurate, where's the benefit other than cost savings and getting results that are of no use?
So I would challenge the view that it's completely useless. So I think in marketing, we think about actually like understanding our consumers and creating value for them. And we need to figure out how to do it better. But talking to them seems to be a really important element of that, much more than sitting in your office and, thinking that pink is a good color and pink is a strategy. So I would challenge that. I'm not saying that conjoint studies is the thing that is the gold standard or the thing that everyone should absolutely do. But this is a way that we use in order to infer prices. And for now, I don't have a better method. So the idea is how can we use GPT to make it more efficient, less costly, and maybe even to get better insights because we can inject different personas, which relates to the first part of your question. So since we posted this paper online, we had a lot of excitement from practitioners, and they have been using something like this, including injecting different personas, and they found it very valuable and also matching their kind of historical studies. Again, you can say that all the studies are BS, and then there's no point in any of this.
But not BS, but just personas is another method that is
Correct.
no longer used by leading marketers. So again, replicating an outdated method with a new way of doing the outdated method, where's the advantage other than cost?
Yeah, that's a fair criticism.
Okay, at that point, we'll have to move on. Thank you
Yeah.
so much.
Yeah,
Fantastic.
Thank you very much.